we have a lot of lesson catching up to do. Medyo marami-rami na yung na-academic is natin. Yan. So, hopefully, you will be able to catch up. By the way, regarding your proposal, so I'm already reading them and I'm sending comments as I read them. For as long as I don't have any comments regarding the overview, you can already start with your exposition. Most of my comments usually nandun sa outline tsaka sa references. So you can go ahead and start with your exposition. The submission will be moved. Supposed to be that's to be submitted during midterm, pero dahil na usog yung activities natin due to academic is usog din natin yung submission. So maybe I'll give you 2 weeks or 3 weeks to finish your exposition. By the way, next week will be our midterm. So the midterm will be as usual. It will be conducted online through Google Form. The form will be open during our class. So just make sure that you have enough data and a stable internet connection during that time. If ever, due to unexpected incidents ay magka-problema kayo sa internet connection nyo, just make it a point to inform me so that we can make arrangements or necessary arrangement for you, so we can either extend the time for the midterm until a sufficient stable connection is established, or we can set it another time. Basta kung magka-problema, inform me si Mayor or inform me ako directly. Okay, so for today, we're going to discuss divisibility in the set of integers. So first, we start with the division algorithm. So the division algorithm gives us a way on how to determine a divisor, a dividend, a quotient rather, and a remainder for two pair of integers. So given integers a and b with b greater than 0, there exist integers q and r satisfying a equals qb plus r, where r is between 0 to b. It can be equal to 0 but strictly less than b. The integers q and r are called the quotients and remainder respectively. Kaya very convenient that we call the number q and r respectively. And this is the result when we do the division of a by b. So, pag may mga instances na meron tayong 2 integers, tas divide natin yung a by b, sometimes we get a result na hindi exact. So, kumbaga yun yung may remainder. For example, just to illustrate the point, pag meron tayong a equals 100 and b equals 15, so we can get 100 divided by 15. So, a calculator will give us 6.666 and so on, right? So, in terms of our division algorithm, that would mean that we can rewrite 100 as 6 times the dividend, the divisor rather, the divisor 15. But 6 times 15 is 90. So, para maging 95 rather. Sorry, that's 90. So, this should be, so this is 90. So, para maging equal sa 100, kailangan pa natin mag-add ng 10. Right? So, that means, in the pair A equals 100 and B equals 15, 100 being the dividend and 15 being the divisor. So, in usual arithmetic, ito yung tinatawag nating dividend. Tapos, ito yung tinatawag nating divisor. So, we can express 100 as 6 times 15, which gives us 90, plus 10. Kumbaga, yun yung kulang para maging, or the remainder. So, when we divide 100 by 15, we get 6 and the remainder is 10. So, this is the quotient. Yung Q natin is our quotient and yung R natin is 10. We can also do that if the number is negative. Medyo tricky lang pag negative yung number. So let's say we have A equals negative 35 and B equals 8. So if we do the usual division, pag ginamit natin ang calculator, negative 35 divided by 8 is negative 4.375. So when you multiply 4 by negative 4 by 8, what you get is negative 32. So para maging negative 35 siya, kailangan pa ng negative 3. But for the purpose of our algorithm, sabi ng algorithm, dapat between 0 to B lang yung makukuha mong value. So this does not satisfy the requirement of the algorithm. Right? So what we can do is we can adjust the value for Q. Hindi negative 4 yung kukunin natin. Kukunin natin negative 5. So observe that negative 5 times 8 is negative 40. So pagka dinagdagan natin siya ng, or para maging negative 35 siya, kailangan dagdagan pa natin ng 5. So this is negative 40 plus yung 5. So that's negative 35. So in this particular example, our Q will be negative 5. And our remainder is 5, which satisfy the requirement that it's between 0 to 8. Right? Strictly less than 8. It can be 0. In some cases, pwedeng 0 yung lumalabas na remainder. Okay. So that's what we mean by a division algorithm. You have two numbers and then you can express the dividend A in terms of QB plus R, where Q is what we call the quotient and R is what we call the remainder. Again, the remainder always must satisfy the requirement that it's between 0 to B. So in this particular theorem, sinet mo natin yung B to be greater than 0. But actually, in general, you can use any non-zero integer. Pwedeng ang divisor ay negative. Pwede yan. Pero later, bibigay na lang natin siya as a corollary of this theorem. So how do we prove the theorem? Paano natin masabi na totoo nga yung theorem? Now, dalawa yung nire-require sa atin ng theorem. First, there must exist Q and R satisfying such equation, A equals QB plus R. And another, actually, this Q and B are unique. Aside from these two existing, unique siya. So let me add that. So it's a unique integers Q and R. Ibig sabihin, there's no other possible values of Q and R that will satisfy. Now, sir, paano yung example number 2 natin kanina? Dalawa yung Q and R. Now, dito sa dalawang example na to, isa lang yung nagsasatisfy ng requirement for R. R being from 0 to B. So, although maraming possible combination ng QB plus R, pero isa lang dun yung magsasatisfy na yung R is between 0 to B. And that's the unique value of Q and R that we want. Yeah. So, let's prove the theorem. So as I've said a while ago, the theorem requires two things from us. First is the existence of Q and R, and then later the uniqueness of Q and R. Sinasabi natin na unique yung Q and R na yan. Yan. Okay, so simulan natin sa uniqueness. Madali lang namang ipakita yung uniqueness. Gagamitin lang natin dyan ay well-ordering principle. So paano yan? Wait lang, nagkaka-technical difficulties lang ako. Okay, sige. Gawin natin to. So, una, magfo-form tayo ng set. So, yung set na is formed by the value A minus XB for all possible values of X to be an integer. Pero we'll add another restriction na gusto natin yung mga A minus XB, mga positive values. Yan. Okay. Kailangan natin mga positive values para magamit natin yung well-ordering principle. First, papakita natin na itong set na to hindi empty. Ibig sabihin may laman siya para magamit natin yung well-ordering principle. Recall well-ordering principle, a set of non-negative integers, meaning mga set ng positive integers or it can have a zero, always has a least element. So pag meron kang set ng mga positive numbers lang, laging merong pinakamaliit doon. Kaya natin inaalis yung negative numbers kasi pwedeng pumunta sa negative infinity pag may mga negative numbers. So, kung puro positive lang, then always may pinakamaliit. So, yun yung well-ordering principle. So, first, papakita natin na may laman yung set na to. Okay. Ano ba yung given? Yung given sa atin, meron tayong dalawang integer a and b with b being positive. B is greater than 0. So, kung B is positive, then at least B is 1. Yan. At least, di ba? Yung A, kahit ano pwedeng value. Pero, para safe, alam natin ang absolute value ng A greater than or equal to 0. Tapos, alam din natin na ang B greater than or equal to 1. Tama? By ano to? By yung hypothesis natin. So, A and B are any integers where B is positive. So, we are always sure that A is, the absolute value of A is greater than 0 and B is greater than or equal to 1. Okay. So, from this inequality, we can multiply the absolute value of A on both sides and we can get absolute value of A times B greater than or equal to absolute value of A. Tama? So, that's just the rule of inequality. Mag-multiply ka ng positive number on both sides, then you still get the same inequality. Okay. So, by addition property of inequality again, mag-a-add lang ako ng A both sides. I can still have the same inequality. Right? Now, on the right side of the inequality, we have A plus the absolute value of A. No matter what the value of A, that will always be greater than or equal to 0, right? Halimbawa, pag ang A mo, positive, de 7 plus 7, 14. Positive pa rin. Pag ang A mo negative, de negative 7 plus the absolute value is 0. So, either ang nakukuha mo lang is twice the value kung positive or 0 kung negative. And in any case, no matter what the value of A is, that's always non-negative. Okay? So, laging positive yung right-hand side. But we can rewrite this as A plus, let's put minus rather. So, this becomes negative of the absolute value B. Kumbaga, nire-write lang natin tong expression na to. So, negative times negative, positive pa rin naman. So, they are still equal and they are always greater than or equal to 0. So, A minus the negative of A times B, which is positive. So, if we consider this to be our X, right? A minus X times B. So, for X equals the negative of absolute value of A, we have A minus XB. To be positive, that means this particular value should be in S. Kasi it satisfies the requirement of S. Ang laman ni S ay ang mga A minus XB kung saan ang A minus XB ay greater than 0, ang X ay integer. So, this particular number here satisfy the requirements of a number being in S. Okay. So, ano yung nakuha natin doon? S is not empty and contains only non-negative integers. So, yun yung mahalagang thought. Hindi siya empty, puro non-negative laman niya. So, now we can use the well-ordering principle. Right? So, ano sabi ni well-ordering principle? Sabi ni well-ordering principle, pag meron kang set ng mga non-negative integers, laging may least element. So by the well-ordering principle, S contains a least element. So by the well-ordering principle, so S contains a smallest integer. So let's call this R na lang. Let's call it R. Okay. So nakita natin na si R is the smallest integer in S. R is the smallest integer in S. Okay. So sure tayo na may nag-exist na ganong value. So kung ano man yung value na yun, tawagin natin R. So yun lang yung sinasabi. Now, since ang R ay part ng S, pwede natin isulat si R in terms of element ni S. Ano yun? A minus an integer times B. So let's say, Q yung gagamitin nating value. So there must exist, automatic, there exists a Q. Tama? Such that yung R, pwede natin isulat as A minus QB. Kumbaga, ito yun eh. Yung R na to, A minus XB ang form niya. Tama? So, kung ano man yung value ng X na magsasatisfy para maging ang A minus XB ay maging equal sa R, yun yung tawagin mong Q. So, there exists an integer Q such that A minus QB is equal to R. Again, because R belongs to S. Na-establish na natin yun eh. R belongs to S. Now, anong alam natin dito? Ang alam pa lang natin, yung R greater than or equal to 0. Kasi yun naman yung mga laman ni S eh. Mga greater than or equal to 0. So, alam na natin na ang R laging greater than or equal to 0. So, kailangan na lang natin establish na ang R ay less than B din. Para kumpleto na yung existence natin. Meron na tayong R, meron na tayong Q. Kailangan na lang yung requirement ng R being from 0 to B. Okay. So, we want to argue that R is indeed less than B. So, suppose this is not the case. So, we want to argue that CR is less than B. So, paano kung hindi yun yung scenario? So, by negation ang gagamitin natin. So, suppose R is not less than B. Ano ibig sabihin pag R is not less than B? Ibig sabihin, R is greater than or equal to B. Yan. Kabaliktaran nung R less than B. So, now we will find a contradiction if we assume that R is greater than or equal to B. If R is greater than or equal to B, automatic yung R minus B greater than or equal to 0, right? We just transpose B on the other side. Pero, ang ibig sabihin niyan, di ba ang R natin ay A minus QB. So, substitute natin yung R na A minus QB minus B is greater than or equal to 0. Right? Yan yung R minus B natin. Kung saan sinubstitute natin yung value ng A minus QB sa R. Pero, kung mapapansin natin, pwede natin i-rewrite itong left-hand side eh. That can be written as A minus yung B common factor. So, factor out mo yung B. So, that's Q plus 1 times B. Right? Tama, di ba? Minus QB minus B, factor out mo yung B, yung negative B, ang matitira sa loob, Q plus 1. Alright. So, that's greater than or equal to 0 daw. Eh, ang Q plus 1, that's an integer. Tama? So, kung integer ang Q plus 1, ibig sabihin, ito ay nasa S. Kasi anything na A minus integer times B na magiging positive, nasa S yun. Diba? Yun ang requirement eh. Lahat ng A minus XB na greater than or equal to 0, nasa S. Okay. So, ibig sabihin, yung R minus B pala nasa S. Yung R minus B nasa S. Wait. Yung R minus B nasa S. Pero di ba yung B ay isang positive number? So, yung R, pag minusan mo ng B, syempre, ibig sabihin, mas maliit yun sa R, di ba? Meron ka number R. Binawasan mo, pinaliit mo pa, o di mas maliit siya sa R. Kasi yung B positive eh. That's not the case kung ang B ay negative. R minus negative number, lalaki yon. Pero dahil alam natin na positive yung B, yung R minus B, mas maliit. Okay. So, dalawang bagay meron tayo. Si R minus B, mas maliit sa R. Okay? Pero yung R minus B, this is also R minus B. Pero yung R minus B, nasa S. Oops. Parang hindi pwede ah. Bakit hindi pwede? Eh, di ba si R is the smallest? Sa loob ni S, pinakamaliit na si R. Ibig sabihin, wala nang pwedeng mas maliit pa kay R. So, imposible na ang R minus B ay nasa S, pero mas maliit si R minus B kay R. This is already a contradiction. Tama? Contradiction yon. E di ibig sabihin, yung inassume natin na to, this is false. After we assume this, nagkaroon ng contradiction. So, by proving of contradiction, di ba? By proof of contradiction, yung inassume natin na R greater than or equal to B must be false. So that only imply that the negation of that, yun yung true. O di ito yung true. So this must be true. So that implies that indeed, R is less than B. So anong nakita natin? Therefore, A is equal to, pag kinuha natin to, sinolve natin si A, so transpose mo lang yung QB sa kabila, QB plus R, where R satisfied the condition that it's between 0 to B. And that already proves the existence. Tama? Ibig sabihin, indeed, makakakita tayo ng Q tsaka ng R that satisfy the equation A equals QB plus R, where R lies between 0 to B. It can be equal to 0 but not equal to B, strictly less than B. And we're done with existence. Okay? So, yun lang yung ginawa natin. Yun lang yung ginamit natin. Kinuha natin yung mga possible A minus XB. May value na si A, may value si B, kunin mo yung A minus XB. Tapos kunin mo yung pinakamaliit na A minus XB na mga positive. Sa mga positive na A minus XB, kunin mo yung pinakamaliit. Yung pinakamaliit, yun yung R. Pag nakuha mo na yung R, masasolve mo na si Q. Tama? Okay. So that means, indeed, there exists such Q and R. Now, how do we show that this pair Q and R is unique? Usually in mathematics, para mapakita natin na unique ang isang bagay, i-assume natin na may dalawang bagay na nagsasatisfy nung ganung requirement. And then eventually, papakita natin na yung dalawang inassume natin na yun ay equal lang pala. So, mathematically speaking, kung equal lang yung dalawang bagay, edi unique yung bagay na yun. Di ba? Di ba? Nakapakita natin na ang 2 ay equal sa B. So, ibig sabihin, yung 2 tsaka B, identically the same. Yan. Okay, so, suppose, meron tayong dalawang pair ng integers Q and R satisfying the same property, satisfying this. So, suppose, meron tayong QR and Q prime R prime. So, dalawang pair ng QR. Isang QR at isang Q prime R prime. Such that, si A, pwede mong isulat ng QB plus R, where R satisfying the condition that it's between 0 to B, and yung Q prime R prime, ganun din. It also satisfy the condition that AQ prime, A is equal to BQ Q prime B plus R prime, where R prime, this time R prime, satisfy the condition being between 0 to B. Yan. So, dalawang set ng QR na nagsasatisfy ng same condition. Okay. So, what we want now to show is that this pair of integers are unique or identically the same, which eventually imply they are unique indeed. Okay. So, from the two equations, we can derive that since both of them are equal to A, pwede natin sabihin na ang QB plus R ay equal sa Q prime B plus R prime. Tama? Equate mo lang si A by transitivity ng equality. Alright. Now, kung equal yung dalawa na yan, So it will satisfy the properties ng equality. Pwede nating ilipat yung Q prime B sa kabila. Tapos yung R sa kabila. So ano makukuha natin? So we can have Q plus Q prime quantity B equals not plus. It should be minus kasi lilipat sa kabila eh. So Q minus Q prime equals, so si R prime yung positive, lilipat yung minus R sa kabila. Yan. Tama. Okay. So, pag in-absolute value natin both sides, so meron tayong Q minus Q prime times B. Yung B positive. So, pag in-absolute value mo yon, B pa din. Times the absolute value of R minus R prime minus R. Okay. So, meron tayong expression involving Q prime and R prime. Okay, balikan natin yung restriction sa R. Ano sabi ng restriction natin? Ang R is between 0 to B. So we can rewrite that restriction this way. Pwede nating i-multiply ng negative 1, so mababaliktad yung inequality. Magiging negative B less than negative R less than or equal to 0. Di ba ganun naman ang rule of inequality? When we multiply a negative number, the inequality is reversed. Okay. Tapos ito, 0 is less than or equal to R prime less than B. So, when you add these two inequality, magkakaroon tayo ng negative B less than negative R plus R prime less than B. So, yung negative R plus R prime pala ay between negative B to B. Right? Between negative B to B. Pero that's exactly the definition of the absolute value, di ba? When you get the absolute value of R prime minus R, pinagpalit ko lang. Pero ito pa rin yan. So that means yung absolute value ay less than B. Tama? These two inequality are the same, ha? Di ba? Definition niya ng absolute value. The absolute value is less than B. Then yung walang absolute value between negative B to B. Alright. So, we established two things. Yung unang inequality, yung unang set of equations na convert natin into this equation, and then yung dalawang inequality for R and R prime na convert natin into this inequality. Yan. Okay. So, what can we conclude from this inequality? Since the absolute value is always positive, we can say that this is between 0 to B. Yung may absolute value ng R minus R prime. Right? Pero, di ba yung absolute value ng R minus R prime equal dito? So, let's substitute that. So, that means yung absolute value ng R minus R prime, which is the same as absolute value ng Q minus Q prime times B, is between 0 to B. Pwedeng mag-equal sa 0, pero strictly less than B. But since B is a common factor, tama, by another rule of inequality, pwede nating i-divide ng non-zero term. Tama? Non-zero yung B na positive. So, divide everything by B. So, ano makukuha natin? So, makukuha natin na ang Q minus Q prime, absolute value between 0 to 1. Pwede equal sa 0, pero strictly less than 1. So, ultimately, what we have is an expression of inequality containing an integer. That's an integer, right? Q is integer, Q prime is integer, absolute value ng integer pa rin, between 0 to 1. Pwede equal 0, pero hindi pwedeng equal sa 1. E di ibig sabihin, no choice na yung value ng absolute value to be equal sa 0. Kasi dalawa lang naman ng integers between 0 to 1 0 at 1. Eh hindi ka pwedeng equal sa 1. Eh di dapat 0 ka na. So that implies ultimately that Q minus Q prime, when you get the absolute value, the result is 0. And there's only one way para mangyari yan. Mangyayari lang yan pag ang Q equals sa Q prime. Right? Yun lang naman nangyayari na ang difference ng dalawa ay 0. Pag equal yung dalawa na yun. Okay. Now, going back to our original equation, this equation, yan. Okay? Alam natin na this time, ito, 0 na to. This is 0. So, 0 times b, 0 pa din. So, that means r minus r prime or r prime minus r is equal to 0. And that only happens if and only if r is equal to r prime. So, ibig sabihin pala, yung q prime tsaka r prime, parehas lang sa q tsaka sa r. Therefore, unique. Okay? So, tandaan nyo yung technique na yun. That will always, almost always appear in a uniqueness, in a proof for uniqueness. Mathematically, when you want to prove that something is unique, what you do is you assume that there are two quantity satisfying the condition, tapos eventually, pwede mong mapakita na equal lang yung dalawang quantity na yan. And that's what we do here. Nag-assume tayo na may dalawang set of QR, may QR, may Q prime, R prime. Tapos, no matter what the value, eventually, magiging equal lang din pala yung dalawa. Eh, they unique nga yun. Right? So, that deals uniqueness. So, since napakita natin na nag-exist yung Q prime, at tapos napakita na natin na unique sila, lagay natin ito. Therefore, QR is unique. Yung pair. The pair QR is unique. And that completes our proof. Okay? Now, as I've said a while ago, pwede naman na ang B negative. So, we can actually get a more general scenario where B is negative. But of course, since nagkuha na natin yung case kanina when B is greater than 0, this is just actually the same case. Pag B is not 0, kukunin mo lang yung dalawang case, case 1, B is positive, case 2, B is negative. Pero syempre, pag B is negative, that would imply that the absolute value of B is positive. So, covered na rin yan dito sa case na to. Tama? So, for as long as yung B not 0, you can always get a pair of integers Q and R satisfying the equation A is equal to QB plus R with R between 0 and this time absolute value of B. Kung ano yung positive. Okay? Absolute value of B. Strictly less than the absolute value of B. Pwedeng maging equal. Again, ang remainder pwedeng equal sa 0. Alright. So, para nangyayari, kinukuha mo lang yung greatest value that you can take away. Parang ilang multiple ng B ang pwede mong alisin sa A. Lahat ng matitira, yun na yung R. Kung ilan lang yung matira. Yan. So, alis ka lang ng alis ng multiple. Okay. So, let's have some examples para tingnan natin kung naintindihan ba natin yung concept. So, let's say we have values of A, pwedeng 2, pwedeng negative 4, 57, negative 80. And we divide it by 11. So, ano daw yung Q, ano daw yung R. Yan, madali lang naman. So, for A equals 2, so let's say A equals 2 and B equals 11. Yan. So, dapat pwede mong isulat si 2 as, yan. Makakakuha ka dapat ng Q times 11 plus R. Yan. Of course, yung 11, mas malaki kaysa sa 2. So, that means, automatic, 0 yung kunin mo. Plus 2. Right? So, your remainder is 2, and the value of Q is 0. Let's have negative 4. Now, dapat si negative 4, masusulat mo as Q times 11 plus something. Alright. Now, yung negative 4, pag nilagay mo dito 0, di ba? Kailangan mo nung mag-add para maging negative 4. So, 0 plus negative 4, this now will not satisfy the requirement. Kasi yung 11 mas malaki sa 4 eh. So parang may tendency tayo na gamitin yung 0. Right? Kaya lang, ang problema yung R, hindi niya sasatisfy yung requirement. Anong requirement? Dapat ang R natin between 0 to 11. Pwede maging equal sa 0 yung R. So hindi pwede yung R na yan. Right? So ibig sabihin, wag 0. Gamit ka ng isang negative 11. Yan. Para pwede ka mag-add ng positive value. So anong kailangan mong i-add? Kailangan mo i-add 7. So now 7 satisfy the requirement that R is between 0 to 11. Yan. Ganun lang kasimple yung idea. Okay. Alakay natin yung value 57, 11. Usually ang ginagawa ko, kinukuha ko yung 57 divided by 11. So isusulat mo yung 57 to be equal to Q times 11 plus something. So pag parang positive, walang problema eh. So 57 divided by 11. So yun lang. So that's equal to 5 point something. Hindi ko na alam kung ano yung decimal part. But if you can determine the decimal part, okay lang. Di ba, may calculator kayo. So pag kinuha nyo yung 57 divided by 11 sa calculator kasi, that gives us 5.18 bar. So hindi naman mahalaga kung ano yung decimal. Ito yung mahalaga, 5. So kung parang positive, kunin mo yung 5. So 5 times 11, 55. So ano na lang yung kulang? That's 55. So, di ba ang R, remember, ang formula ng R is QB minus, A minus QB. A minus QB. O, gagawin mo lang, ito, minus ito. So, that's 2. Okay? O, ganun lang. Now, magkakaroon lang naman ng konting variation yung technique na to pag may negative na na-involved. Yan. At tingnan natin yung negative na involved. So, pag involved si negative, so ganyan ulit, negative 80, di ba? Divide mo ng 11. So, halimbawa, may calculator ka, 80 divided by 11. Sa calculator yun, negative 7.27. Dito na sa, burahin ko lang to. So, 80 divided by 11, pero negative yung 80, that's negative 7.27. Kanina, nung ginawa natin yun dun sa negative 4, hindi umubra yan eh, yung 0. So, gagawin mo, imbis na negative 7, kukunin mo yung, ang tawag natin doon, lower, parang GIF function, pero hindi yung exactly GIF. Yung floor ang kukunin mo, yung nasa babang integer. Kasi yung negative 7.21, between negative 7 to negative 8. Yung ceiling function, yung negative 8. Yun yung GIF. Ay, sorry, baliktad ako. Negative 8 dito, negative 7. So, pag ginawa mo yung GIF, negative 7 lalabas. So, ang kukunin mo, hindi yung negative 7. Ang kukunin mo yung negative 8. So, ang tawag doon, floor function. So, negative 8, so that's negative 80 is equal to negative 8 times 11. Now, that gives us negative 88. So, kailangan ka pang mag-add ng para maging 80 plus 8. Now, that satisfy the requirements na between 0 to 11. Take note na kung ang kinuha natin ay yung negative 7, magkakaroon tayo ng negative 7 times 11, which is negative 77. Ang kailangan natin i-add para maging negative 80, negative 3. And that does not satisfy this requirement. So, imbis na negative 7, wag yung integer part yung kukunin. Ang kukunin, yung floor function ng integer part na yun. So, ang floor function ng negative 7.21, negative 8. Again, ang floor function, yun yung integer na less than or equal dun sa value ng quotient. Okay. So, now what if we make the divisor negative? So, ano mangyayari pag ginawa natin negative yung divisor? So, let's say we have 2 and negative 11. So, what we want is for R now to be between, hindi na between 0 to B, kasi negative yung B eh. So, absolute value ng negative 11. Yan, which is still 11. Yan. So, pag kinuha mo yung 2 equals, hindi na 11 ang i-multiply mo, negative 11 na, plus something. So, this time, hindi mag-work yung 0. Kasi pag 0 nilagay natin, nga, plus 2. Yan. Mag-work pala yung 0. 0 times 11, yung mamaya pala yung sinasabi ko. 0 times negative 11, 0 pa din, so that's 2. Okay, negative 4 and negative 11. Yan. So, negative 4 equals negative 11 plus, well, kung matatandaan mo yung ginawa natin kanina, yung negative 4 equals sa negative 1 times 11. Tama? Plus 7. So, this time, yung negative, dahil nandun na sa 11, ang matitira na lang sa labas, 1. Plus 7. Okay? So, lalaruin mo lang yung value. Kung alam mo na yung part na to. Now, 57 and negative 11. So, gusto mong isulat yung 57 to be times negative 11 times something plus something. Okay. So, kung alam mo na to, madali nang makuha yan. Kung alam mo na yan. Alam mo na yung 57 ay 55 plus 2. Right? So, ang gagawin mo lang, since negative 11 yung divisor, ini-negative mo lang din yung quotient para maging negative times negative, positive. So, that still is 55. So, 2 pa rin ang requirement. Alright? And finally, pagka negative 80, so dito na lang, negative 80 can be written as times negative 11 plus something. So, kung alam mo na to, so all you need to do is to make up for the negative. So, since nandun na yung negative sa 11, 8 na lang to. Plus 8. Ay, wait lang. Ba't parang mali yung ano ko? Tama. Negative 88 plus 8. Right. Okay. Na-confuse ng konti si sir. Question po sa division algorithm. Wala naman. Okay. Now, kanina sabi ko, possible. Di ba? Possible na yung R natin equal sa 0. That actually happens when the value of A is what we call divisible by B. Ibig sabihin, pag yung mismong divisor na ginamit mo ay factor nung A, magiging 0 yung remainder. Yan. So when that happens, we say that A is divisible by B. So, what do we mean by divisibility? Okay. Magpapalitin ko lang yung value ng B at A. An integer B is said to be divisible by A. Yan. Kung saan yung A is a non-zero integer, of course, we don't have division by 0. So, we don't divide a number by 0. So, B is said to be divisible by a non-zero integer A if there is an integer C such that B is equal to AC. So take note that in our division algorithm, the value of R here is 0. Baga parang nasulat mo si B as Q times something plus times A plus 0. Yan. Kinamit ko lang na C yung sa variable. Pero galing din yan sa division algorithm. So if you can write B as product of A times a number, then we say that B is divisible by A. Yan. In other terminology, sinasabi rin natin na ang A divisor ni B or ang A factor ni B or si B multiple ni A. Yun yung mga ibang terminology. So, this symbol A divides B is used to mean divisibility. Okay? So, ang ginagamit natin, yung vertical, parang nakatayo na bar, na parang sa absolute value. That's the reason why sometimes, pag gumagamit ako ng set, kung napapansin nyo, X is an element of S. Lagi nga ginagamit yung such that colon. Hindi, di ba yung iba ang ginagamit ay bar, yung vertical bar. Yan. Yan yung ginagamit ng iba. So, kaya iniiwasan ko to dahil sa meaning ng divisibility. So, magkakaroon ka ng confusion. Halimbawa, sinabi ko, X is in S such that X divides B. O, yan, patay tayo dyan. So, anong ibig sabihin? Di ba? Nagkakaroon na tayo ng confusion or abuse sa notation natin. Kaya iniiwasan ko yung symbol na to mean such that. So, usually, ganito yung ginagamit yung symbol. Yan. Okay? Pero kung kaya nyo i-differentiate, di okay lang naman. Pero as much as possible, we don't want to abuse our notation. Okay. So that's what we mean by divisibility. Now, in the case that A does not divide B, nilalagyan mo lang ng slash. And always naman in mathematics, we use slash to mean not. So if A is not divisible, if A does not divide B, or B is not divisible by A, then we use the symbol A does not divide B. Yan. Now, if A divides B and A is strictly less than B, of course, A is never equal to 0, then we call A proper divisor. Kasi alam naman natin na any number divides itself. So, in our definition, pagka yung pareho, yung A and B equal, hindi proper yung A. So, a proper divisor is a divisor that is strictly less than B. Okay. So, here's our properties of divisibility. Medyo madami lang. Pero they are easy to remember naman, and we've almost already used all of them one point or another nung high school tayo or nung elementary tayo. Okay. A divides 0, that's obvious. 1 divides A, and A divides A. Yan. Number 2, A divides 1 if and only if A is either positive 1 or negative 1. So, ang mga divisor lang, sinasabi ng number 2, ang mga divisor lang ni 1 ay positive 1 at negative 1 and no other. Number 3, A divides B and C divides D. So, meron kang apat na number. Si A dinidivides yung B, si C dinidivides yung D. Then, their product also divides the other product. So, pag minultiply mo yung A tsaka yung C, madidivide din niya yung B tsaka yung D. Yan. So, the product of the divisor divides the product of the dividend. Yan. Kaya tawag natin doon product rule. A divides B and B divides C implies A divides C. So, yan yung tinatawag natin transitivity. A divides B and B divides A implies A is equal to B or negative B. Ibig sabihin, pag ang A divides B at ang B divides A, dalawa lang pwedeng scenario. Either equal sila or negative sila ng isa't isa. Ang tawag natin doon is the anti-symmetry property. Yan. So, if you remember, sa set theory, meron tayong tinatawag na symmetric property tsaka anti-symmetric relations, di ba? So, yung divisibility pala, yung relation na A divides B, hindi pala siya symmetric property. That's actually anti-symmetric property. Okay, A divides B and B is not 0. So that would mean that the absolute value of A is less than or equal to the absolute value of B. So kung titingnan mo yung magnitude ng A tsaka ng B, pag ang A, dinidivide niya sa B, so pag ang A yung divisor, laging less than or equal siya doon sa dividend. Yung magnitude, in terms of magnitude. Okay. Kasi pag may negative, yung negative value, mas malaki yung magnitude, mas negative siya, mas less siya. So yung magnitude. Ang magnitude ng A, mas maliit sa magnitude ng B pag ang A ang divisor ni B. Yan. A divides B would mean A divides BX, where X is any integer. So, pag meron daw tayong A divides B, si A, kaya din niyang i-divide lahat ng multiple ni B. Multiple. A divides B and A divides C. So, pag ang A, dinidivide niya parehong si B tsaka si C, then A will divide any linear combination. Ibig sabihin, si B multiply mo sa kahit anong number, si C multiply mo sa kahit anong number, i-add mo silang dalawa, yung result, divisible ba rin by A. If M is not 0 and A divides B, then MA divides MB. So, parang ito factor. Pag finactor mo yung divisor, factor, tapos common factor siya ng dividend, pwede mong tanggalin yung common factor and still A will divide B. Okay. Isa-isayin natin. Prove natin to. Medyo mahaba lang but the proof are quite easy to understand. Okay. Number 1, 3 simple properties, A divides 0. So, sa proof, kailangan mo lang naman ipakita that it satisfies the condition of divisibility. So, that means you just have to remember what does divisibility mean. Kailangan mo lang maghanap ng factor. Maghanap ng imumultiply kay A para maging equal sa B. Okay? So, pag nakakita ka ng imumultiply sa dividend, sa divisor, para maging equal sa dividend, then it's divisible. A divides 0 daw. So, bakit A divides 0? Kasi ang A, pwede mong isulat as, rather, A divides 0 pala. So, 0 dapat yung isusulat natin. 0, pwede mong isulat as A times 0. Ang requirement lang naman, doon sa minultiply mo sa A, integer siya. Diba? Sabi ng definition, there exists a C. Integer C, such that you were able to write the dividend as the divisor times C. So, we want to say that A divides 0. So, kailangan natin isulat si 0 as A times something. Ang 0, A times 0. So, that means, indeed, A divides 0. 1 divides A. So, kailangan mo lang isulat si A as 1 times something. Pero, ang A ay 1 times A. Tama? By multiplicative identity. O, di ibig sabihin, si 1 divides si A. A divides A. Ang A equals sa A times 1. Basta kailangan ka lang humanap ng integer. Yan. So, sinusunod lang natin yung form ng definition. So, yung A na to will divide yung A na to. Yan. Dito, yung A divides yung 0. Hindi natin pwedeng gamitin yung 0 as divisor, ha? So, walang 0 does not divide any number. Hindi tayo pwedeng mag-division by 0. Okay. Tapos, dito sa requirement na to, yung A natin non-zero. We always assume that A is non-zero here. But actually, in our division of divisibility, 0, technically speaking, 0 will divide 0. 0 divides 0 by definition. Pero it doesn't equate, it doesn't necessarily mean that 0 over 0 exists. Hindi pareho yung expression na A divides B sa B divided by A. Magkaibang expression yan, ha? Okay. Technically speaking, if we use our definition, 0 is equal to 0 times 0. So, ibig sabihin, kung yung A 0, we can have an expression na 0 divides 0. Pero, sa definition natin, we require A to be non-zero. So, that eliminates the possibility that yung divisor natin 0. Okay? Yan. So, technically speaking, sa definition, pwedeng mangyari to, pero adding the non-zero condition will eliminate this possibility. Yan. Okay? So, always in our definition, the divisor is non-zero. So, we're good with 1. Number 2, A divides 1 if and only if A is plus or minus 1. Right? Okay. So, the only divisors of 1 we know for a fact are 1 and negative 1 only. Tama? Yun lang naman yung tanging possible scenario. Yung divisor ni 1 is 1 or negative 1. So, if yung papunta rito, kasi if and only if yan. Yung papunta rito, we're already good. If A is 1, then A divides 1. If A is negative 1, then negative 1 divides 1. Right? Now, if A is equal to 1, if A divides 1, if A divides 1, dalawa lang yung possible scenario. Either A is equal to 1 or A is negative 1. Tama? And in the other direction, yung papunta sa kabila, if A is equal to 1, you already know that 1 is equal to 1 times 1. And if A is equal to negative 1, we already know that 1 is equal to negative 1 times 1. In either case, A divides 1. Okay. Dahil lang naman yung number 2 eh. Next, A divides B and C divides D. Then, AC divides BD. Again, the idea is to follow the definition and show this property, show this expression. So, ang gusto natin ipakita, AC divides BD. Yan. Okay, so let's look at number 3. Meron tayong A divides B, tsaka C divides D. Pero ano bang ibig sabihin nito? Well, by definition, if A divides B, then B can be written as A times C. Similarly, hindi pwedeng C pala, no? Kasi may C, ma-abuse yung notation. Gamitin natin Q1. Similarly, D can be written as C times Q2. Yan. Hindi ko ginamit yung C kasi may C na involved. Eh. So, ma-abuse yung C. Alright. So, ibig sabihin, we can rewrite BD as A times Q1 times C times Q2. Or meaning, we were able to write BD as AC by commutativity of multiplication times Q1, Q2. Now, since Q1 and Q2 are both integers, then this is also an integer. So, ano nangyari? Na-write natin yung BD as the product of AC and an integer. So, ano ibig sabihin nun? So, therefore, si AC divides BD, which is what we want. Yan. So, we're good with 3. A divides B and B divides C. By transitivity, A divides C. Alright. So, madali lang naman yan. Laging itatranslate mo lang into definition. Si A daw nadidivide si B. At si B nadidivide si C. So, anong ibig sabihin? By definition, si B, pwede mong isulat as A times Q1. Si C, pwede mong isulat as B times Q2. So now, these two will imply that C is equal to yung B, papalitan mo ng value ng AQ1 times Q2. But again, by associativity of multiplication, si A nasulat mo as, si C rather, nasulat mo as A times Q1, Q2. Again, this expression here is an integer. So, si C ay equal to A times integer. So, therefore, A divides C. Okay? Ganun lang po kadali mag-prove ng divisibility. You always go back to the definition. So, from the given, gamitin mo yung definition and then establish mo yung conclusion required. Yan. Okay. So, tuloy natin. A divides B and B divides A implies A is equal to plus or minus B. Yan. Well, madali lang naman yan eh. Ano ba ibig sabihin ulit ng definition na A divides B? Anong given pala na A divides B and B divides A? Okay. So, ang given, A divides B, B divides A. So, by definition, si B, doon sa una, pwede mong isulat as A times something. Pero from the given, from the second given, si A, pwede kong isulat as B times something. Tama? Huwag niyong pagkakamukain yung something kasi magkaibang value yun. Unless mapapakita mo eventually na equal sila. Okay. So for some integers Q1 and Q2, we're able to write B is equal to A times Q1, A is equal to B times Q2. Okay, pagsamahin mo ngayon yung given. Yung nakuha natin, pag pinagsama natin, ang ibig sabihin, si B na equal sa AQ1, pwede mo i-substitute yung A doon. So that's equal to B Q2 Q1. Tama? Okay. So, easily, since common factor yung B, pwede natin i-factor out yung B. Di-divide natin by B. We have an assumption here that B is not 0 naman. So, pwede natin i-divide by B. So, matitira, 1 is equal to Q2 Q1. Meron tayong product na nag-equal sa 1. Well, ano ba mga integers na pag minultiply mo, nagiging equal sa 1? Aba, dalawa lang ang possible scenario, di ba? Either yung Q1 equals Q2 equals 1. Para pag multiply mo, 1 times 1, 1. Remember, ang Q2 at Q1 parang integer. So, hindi pwede yung 1 half times 2, hindi pwede yung 1/3 times 3. Integers lang dapat. Okay. And, or si Q1 equals sa Q2 equals sa negative 1. Yun lang yung pwede mangyari. Either pareho silang 1 or pareho silang negative 1. Pag binalik natin yun sa equation natin, so parang sinasabi mo na pag sa case na to, ibig sabihin B is equal to A. Sa case na to, ibig sabihin B is equal to negative A. So that means A is equal to plus or minus B. Okay? Okay tayo sa 5. Again, all you need to do is to show the definition. Yan lang kadali. Okay. Ano sunod? We want to show that if A divides B and B is not 0, then the magnitude of A is less than the magnitude of B. Yan. Okay. Again, definition lang naman yung kailangan dyan. So, pag kinuha natin yung absolute value nung definition, paano natin yung requirement ng inequality? Paano yan? So again, ang given, A divides B, di ba? Ano ba ibig sabihin ng A divides B? Since A divides B, that would imply that B can be written as A times something. Yan. B is equal to AQ. So, kunin natin yung absolute value. Kasi may absolute value involved. So, absolute value ng A times absolute value ng Q. Tama? Okay. So, dahil yung absolute value ay positive naman, so, ito positive. So, this is greater than or equal to absolute value of A. Yan. Okay. Bakit ulit sinabi natin na nasang number na ba tayo? Number 6. A divides B. Namunta ko yung conclusion na kailangan. Less than. Okay. So, A divides B and B is not 0. Yan. B is not 0. Mahalaga yung requirement na B is not 0. Bakit? Kailangan yung requirement na B not 0 para masabi natin na yung Q na to not 0. Kasi special case, pag ang B is 0, edi A still divides B. Diba? So, kung hindi 0 si B, ibig sabihin, yung multiple na i-multiply mo kay A, hindi rin 0 yon. Yan, okay. So, dahil hindi siya 0, yung absolute value niya, greater than 0. Tama? Yung absolute value niya, greater than 0. So, at least, yan ay 1. So, pwedeng 1, pwedeng 2, pwedeng 3. So, basta not equal to 0, pag in-absolute value mo, greater than or equal to 1. Absolute value ng Q ay greater than or equal to 1. Yan. Kaya, yung product na to, greater than or equal dito. Hindi, ito na yung inequality na kailangan. Yung absolute value ng A ay mas maliit sa absolute value ng B. Yun. So, okay na tayo. So, 6. Diba? A divides B implies A divides BX. Okay. So, X is any multiple. X is any integer pala. So, that means BX is any multiple. So, I leave this as an exercise. Madali lang naman yan. Para ma-practice naman kayo. Diba? A divides B and B divides C. And A divides C. Then A divides the linear combination. Again, exercise. Gagayahin nyo lang naman yung technique na ginagawa ko dito sa from 1 to 6. Ililipat mo lang to sa definition and then kukunin mo yung value nito at ipapakita mo na may factor siya na A. Yan. Parang yung ginawa natin dito. Kinuha mo yung definition nito, tapos kinuha mo yung product BD, pinakita mo na may factor siya na AC. Kinuha mo yung definition ng A divides B, kinuha mo yung definition ng B divides C, sinold mo yung C, pinakita mo na may factor siya na A. So, ganun lang yung pagpapakita ng divisibility. So, kunin mo yung definition nito, tapos isolve mo yung linear combination na to, ipakita mo na may factor siya na A. Okay? Yan. So, exercise para ma-practice. Yan. If M is not 0 and A divides B, then MA divides MB. If MA divides MB and M is not 0, then A divides B. So, pwede ka raw mag-factor, makumuha ng common factor, tapos yung matitira, still divisibility holds. Yan. Madali lang yan. Yeah. Pakita natin. Medyo tricky lang ng konti yung factor. So, 7, 8, exercise. Number 9. Ano ba ibig sabihin ng A divides B? Diba? If A divides B, then ibig sabihin, by definition, B is equal to A times a number. Okay. So, pag minultiply mo yan ng M, for as long as M is not 0, syempre, MB equals MAQ pa din. Tama? Well, ano ba ibig sabihin nito? Sa divisibility. So, ito MB, ito MA. So, ibig sabihin yan, MA, ito, nasulat, na multiply mo ng integer, naging ganito. So, MA divides MB. And we're done. Application lang ng definition. Yan. Okay, with all these talks of divisibility, so nakakita tayo ng idea ng mga divisor. Yan. So let's define what we mean by a divisor. Wait, anong oras na ba? Baka kailangan natin mag-break. Sige, pagkatapos ng GCD break tayo. At any moment in time, you can log off or log out pag may na internet connection or kulang sa data. Anyway, this is recorded. So again, I'll just upload the recordings later sa Google Classroom. If A and B are arbitrary integers, then an integer D is a common divisor of A and B if both D divides A and D divides B. Yan. So, pag meron daw tayong dalawang integer AB, tapos may third integer na parehong divisor ni A tsaka ni B, then ang tawag natin doon, common divisor. Yan. Napaka-intuitive naman ng mga definition natin, di ba? One is a common divisor for any pair of AB because of the first theorem that we have. One divides any number. So, laging common divisor si 1. Now, if both A and B are 0, then any integer is a common divisor. Again, yung first property natin, di ba, sabi natin, any number divides 0. So, pag ang AB natin, parehong 0, lahat ng integer, divisor nun. Di ba? So, lahat ng integer, common divisor. So, those are the trivial cases. One is a common divisor for any pair of integers. And if it happens that A and B are both 0, then every integers are common divisors. So, medyo hindi magandang example pag parehong 0, di ba? So, from here on forward, whenever we say common divisor, we will now exclude the possibility that both A and B are 0. So, laging idadagdag natin na not both 0. Pwedeng yung isa sa kanila 0, pero not both. Okay? So, let A and B be integers, not both 0. The greatest common divisor of A and B, denoted as GCD-AB. Yung ibang literatures, ganito lang yung ginagamit nilang notation ng GCD. Kaya lang, syempre, minsan, pag nagbabasa ka, baka mapagkamalan mong Cartesian pair. Baka mapagkamalan mong coordinate AB. Yan. So, nilalagay ko na yung word na GCD just to avoid the confusion. So as not to abuse the notation for the coordinate pairs AB. So the GCD of AB is the positive integer D satisfying. Since it's a greatest common divisor, then it must be a common divisor. So, yun yung number 1. D is a common divisor. Meaning, D divides A and D divides B. And we want this common divisor to be greatest. So, number 2, if C is another common divisor, meaning C divides A and C divides B, then C must be smaller or equal to D. Para yung D yung pinakamalaki. Yan. Again, very intuitive naman yung ating definition. The greatest common divisor is the greatest of all the common divisor. Yan. Very easy to remember. Just to illustrate, let's find the divisors of 54 and 72. Yung 54, sometimes pwede natin gawin, simulan natin sa maliit. Of course, yung 1, laging divisor na yan. Pero pag divisor ang 1, automatic, yung negative niya, divisor din. Lagi naman yan magkapares lagi ang positive at negative divisor. Okay. Ano ba obvious na divisor ng 52? 2. So, plus minus 2. 54 divided by 2 gives us 27. So, yung mga iba pang divisor, mga divisor ni 27. So, plus minus 3. Divisor din yan. 2 times 3, 6. So, 6 is also a divisor. Di ba? Kasi 9 times 6 is 54. Yan. 3 times 3, 9. That's also a divisor. Yan. 6 times 2, 12. Divisor ba ang 12? Nasaan na tayo? Hindi. Kasi, ang greatest niya na factor, 2 na. So, hindi na niya, yung 12, 4 times 3 So, hindi na pwede. Pero yung 2 times 9, 18, divisor pa din. 18 times 3, di ba? So, plus minus 18. Of course, yung sarili niya, tsaka yung negative niya, divisor din. Ayan yung mga divisor ng 54. Yan. Ano naman ang mga divisors ni 72? Siyempre, plus minus 1. Divisible din siya sa 2. 72. 72 divided by 2, 36. So, hinahanap natin mga factor ng 36. Diba? Ano ba ang 36? 36 ay 2 times May na ako sa arithmetic 18. Tama? So, yung 18 may 3. 2 times 9. So, divisor din yan, 3. Yan. So, dinidivide siya ng 2 at most 3 times. So, pwede niyang divisor ang 4. Pwede rin yung divisor ang 8. Yan. Si 3, dinidivide siya at most 2 times. Tama? So, pwede niyang divisor ang 9. Alright. Actually, ang 6, divisor din niya. Kasi divisor niya ang 2, divisor niya ang 3. Yan. Ano pa pwede? 4 times 3, 12. Divisor din yan, 12. Diba? So, those are the possible divisors. Marami pa. Isa-isa na natin. Completoin na natin. Meron ding 18, tama? Meron din 24, plus minus 18, plus minus 24. Ano pa? Plus 36, plus minus 36, plus minus 72. Yan. So, alin yung common divisor? E, hanapin mo lang. Ito, common. Yan. Ito, common. Alin pa? 9, common. 9. 18, common. Wala na. So, those are the common divisors. So, by definition, of all these common divisors, hanapin mo yung pinakamalaki. So, sa mga common divisors, ang pinakamalaki, 18. So, ibig sabihin, this is equal to 18. Yan. Of course, alam ko na meron pa kayong ibang technique para mahanap yung greatest common divisors. Eventually, we'll go there. Iniisa-isa lang natin yung definitions. Given integers a and b, not both 0, there always exist integers x sub 0 and y sub 0, such that the greatest common divisor can be written as the linear combination ax0 plus by0. This is an interesting theorem kasi nasusulat nito yung GCD as linear combination ng AB. Ang problema lang, medyo mahirap hanapin yung x0 at y0. Yan. Pero, ang importante, yung existence. Ibig sabihin, sinasabi niya na pwede mong isulat, makakakita ka ng dalawang integer x0, y0, such that yung linear combination ax plus by ay equal sa GCD. So, ang GCD pala ay isang linear combination ng AB. Okay? Ang GCD ay isang linear combination ng AB. For example, para lang sa madali mo nang makita. Halimbawa, meron tayong 8 and ano ba ang dami ko para sa 8? 12. 'Di ba ang GCD ng 8 tsaka ng 12 ay 4. Okay? Kasi ang factors ng 8, 2 times 2 times 2. Ang factors ng 12, 2 times 2 times 3. So, GCD yung 4. Okay. Pag maliit yung number, madali lang i-mental calculation eh. So, ganun lang naman ginagawa natin. So, okay lang yung mga technique natin ng high school. Now, ang sinasabi ng theorem, si 4 pwede kong i-express as linear combination ng 8 tsaka ng 12. Kaya lang, hahanap ka lang ng value x0, y0. In this particular example, madaling hanapin eh. Di ba? Paano yun? Gawin mo lang 1 yung sa 12, negative 1 yung sa 8. Yan. So, 8, negative 8 plus 12, 4. Tama? Yan. Hindi unique ang linear combination na to ha. Ang sinasabi lang natin, there exist integers. Pwede ka rin maghanap ng iba pang linear combination. Halimbawa, pwede rin naman na 8 times 2, 16 plus negative 1 times 12. Tama? That's 16 minus 12, 4 pa din. So, hindi unique yung linear combination, pero ang sinasabi ng theorem, meron. Meron ka makikitang x0, y0. So, anong advantage nun? Ang kagandahan nun, pag alam mong kunin yung linear combination, ibig sabihin, may way ka para hanapin yung GCD. through the linear combination. So it's a possible way to arrive to the value of a linear combination. At this point, parang pwede natin isipin, sir, tedious naman yan. Pero later, we'll see the advantage of this method. Okay, so, ang gagawin natin, para ma-prove tong theorem natin, so, ang gagawin natin, i-create natin yung set ng mga linear combinations. Tapos, hahanapin natin, or gagawa tayo ng way para mahanap din yung specific number x0, y0 that we need. Now, consider now the set S equals, so again, since ang gusto naman natin talaga is of the form ax plus by, so yun yung buuin natin set, ax plus by. So let's say we have this set for all the possible linear combinations ng AB. So ax plus by where x and y are integers. And of course, we want to restrict this to positive values. So kukunin lang natin yung mga ax plus by na greater than or equal to 0. Okay. Of course, this set is not empty. Ibig sabihin, automatic na tayo dapat na may laman. Bakit? We have a requirement that not both A and B are 0. Tama? So if we assume that, let's say, yung A yung hindi 0, kasi not both naman eh. So at least may isang hindi 0. So if A is not 0, then automatic, pwede nating sabihin na yung A either greater than 0 or A is less than 0. If A is greater than 0, then we can write A times 1 plus B times 0 to be equal to A. And we know that that's positive. Right? Now, on the other hand, if A is negative, so ang gagawin lang natin, i-multiply natin yan ng negative 1 plus B times 0. So, ang magiging sagot, negative A. Now, since A is negative, yung negative A, yun yung positive. In either case, nakakuha tayo ng linear combination ng AB. So, meron tayo nakuhang XY, such that AX plus BY is positive. So, that means, depende kung yung A ay positive o negative, in either way, this belongs to S. Or ibig sabihin, S is not empty. Okay? So, sure na tayo na ang S not empty. At sure din tayo na puro positive lang yung laman ni S. Or pwede rin 0, siyempre. So, ano ibig sabihin nun? So, that means that S, again, by the well-ordering principle, must contain a least element. Diba? Kasi subset siya ng mga positive integers eh. So, we always use, in that case, the well-ordering principle. By the well-ordering principle, S must have a least element. Yan. S contains a least element. So, sa lahat ng mga positive AX plus BY, kunin mo yung pinakamaliit. And let's call it D. Check tayo na merong ganun. Okay. So, ang gagawin natin, si D, since part siya ng S, ibig sabihin, isa siyang linear combination ng AB. Diba? So, there exists X sub 0, Y sub 0, such that D is equal to A times X sub 0 plus B times Y sub 0. So, we already see na itong value na to ay linear combination ng A tsaka B. So, all we need to do is to show that D is the greatest common divisor. At this point, di pa natin alam kung siya nga yung greatest common divisor. So, yun yung next step. Kailangan natin ipakita na siya yung greatest common divisor. Okay, so paano yan? First, we need to show na indeed, it is a common divisor. Di ba? Tapos, pagka nakita na natin na common divisor siya, kuha tayo ng isa pang common divisor, tapos ipapakita natin na laging mas malaki siya, yung D, kaysa dun sa iba pang common divisor. Yan. Okay, so let's start. Let's first show that D is a common divisor. Okay. So, first, observe that by using division algorithm on A and on D, so use natin, use division algorithm on AD. Okay. So, anong sinasabi nito? There exists, di ba? There exists Q1, R1 such that city A, pwede natin isulat as Q1 D plus R1. Of course, R should satisfy the requirement of the division algorithm. So, sa division algorithm, ang ginawa nating pair A tsaka D, D yung magiging divisor, A yung dividend. So, yung R must be between 0 to D. Diba? Yun yung requirement ng division algorithm. So, yung R1 is between 0 to D. Yan. Okay. So, pwede natin isulat si R from this equation. Pwede natin isulat si R1 to be A minus QD. Yan. Okay. Now, again, saan ba equal si D? Si D ay equal sa Q1. Si D. Ito si D eh. AX. Yan. So, that's AX0 plus BY0. Okay. So, pag regroup natin yung expression such that magkasama yung A, so we have A quantity 1 minus Q1 X0 plus B Y0. Tama? Finactor out ko lang yung A. So, matitira dito ay 1. Matitira dito Q1 X0. Yan. Plus, I just rewrite. So, this should be, naka-times lahat yan sa Q1 eh. So, plus times, meron pa tong negative Q1. Yan. Sorry, let me rewrite that ng mas maganda. Plus B times quantity negative Q1 Y0. Yon. Okay. So, what does this mean? This would mean na naisulat natin si R as linear combination ng A tsaka ng B. Tama? Nasulat natin siya as linear combination ng A tsaka ng B. Now, if R is greater than or equal to 0, this would imply that R belongs to S. Kasi lahat ng linear combination na positive ni AB na positive na kay S. Tama? So if R is greater than or equal to 0, then that would definitely mean that this particular value R1 pala yung ginamit ko. This particular value R1 must belong to S. Pero since R is less than D, because of this, diba? Since R is less than D, this would contradict the choice of D. Hindi pwede na si R mapupunta sa S pero less than D siya. Tama? Ulitin natin. If R is less than D, we have a contradiction. Again, asan yung contradiction? Nakakita tayo ng R1 na laman ni S. Pero, mas maliit siya kay D. Si D yung smallest. So, hindi pwede na si R1 less than D. Hindi pwede yon. Because that would mean that R1 is smaller than D, making D not the smallest element. Sabi nga natin, D na yung smallest eh. Okay. So, that means R1 is not less than D. Hindi pwedeng mangyari na ang R1 less than D. So, ano na lang yung natitirang possibility? So, ang natitira na lang possibility is that R is 0. So, therefore, ito na lang yung naiwang possibility. So, nasulat natin, O, di wala na to. 0 na lang pala to. So, nasulat natin si A as D times Q1. Adi ibig sabihin, D must divides A. Tama? D divides A. Now, following the same argument for this time B and D, ulitin lang natin yung argument natin. So, for B and D, by division algorithm, there exists Q2 and R2 such that B can be written as D times Q2 plus R2. Pag inulit mo yung argument na to, since D is equal to AX0 plus BY0, eventually, makakakita ka rin ng contradiction sa R2. Pagka ang R2 ay less than D, pero greater than 0. And that would also imply that R2 is 0. So eventually, again, you just have to follow this same argument. Kasi you can write R2 in terms of A minus Q2D. This time, magiging B lang to. This becomes B. For R2, this becomes B for R2. Di, ganun pa rin yung takbo ng argument. So if R2 is less than D, magkaka-contradiction ka. This would imply that R2 is equal to 0. And therefore, B can be written as D times Q2, which implies that D divides D. Using these two arguments, we're able to show that D is a common divisor. Yan. Hence, D is a common divisor of A and B. Now, isa na lang yung kailangan natin ipakita. Napakita natin na common divisor siya. So, ano na lang ang kulang? Kulang na lang, ipakita natin na siya ay greatest of all the common divisor. Right? Okay. So, paano yan? Finally, to show that C is a common divisor, D rather, is a common divisor, let's assume that there's another common divisor. So, assume C is a common divisor of A and B. Ibig sabihin, C divides A and C divides B. Okay? So, ang mangyayari, kung meron kang common divisor, by our property, kung naalala nyo pa yung property natin, sabi ng property, any linear combination, that's your exercise, that's property 7. Any linear, 7 ba or 8? Nakalimutan ko na. So, any linear combination ng, kasi common divisor eh. May common divisor ka ng A at B. So, any linear combination ng AB must be divisible by C. Yun yung sinasabi nung property natin. Nakalimutan ko na kung anong number. Okay. So, that means C should divide any linear combination AX plus BY. Tama? Okay. Pero di ba si D is a linear combination? Tama? So that would imply na C divides D. Kasi linear combination siya eh. Linear combination, si D, linear combination eh. Yeah. Meron tayong D equals AX0 plus BY0. Eh, nakita natin na pag ang C common divisor, then C must divide any linear combination of A and B. In particular, C divides D. Sabi nung susunod na property, if C divides D, then C, yung absolute value ng C, less than or equal sa absolute value ng D. Tama? Basta divisor ka, ang magnitude mo mas maliit kaysa sa D. Well, yung pinag-uusapan natin mga common divisor ay positive value naman, di ba? Yung common divisor natin ay positive kasi requirement yun ng S. Ayun. So, ibig sabihin, si C mas maliit kay D. Kasi yung D positive. Alam natin yung D yung positive. Eh. So, pag tinanggal natin yung absolute value, the inequality still holds. Therefore, C is less than D. So, napakita natin na first, D is a common divisor. Unang-una pala, hinanap natin yung D. We were able to show that there exists a D satisfying this. And then we show that D is a common divisor. So, D divides A and D divides B. So, D is a common divisor. And then we were able to show na if there's another common divisor, then that's smaller than D. Which is smaller. They were able to prove the theorem that indeed, this particular number here is the GCD of AB. Yan. Again, at this point, it's quite tedious to determine GCD using this process. Medyo hindi convenient gawin. Kasi gagawin mo, hanapin mo lahat ng linear combination. Pero using a computer, that's possible. Meaning, if you can perform or if you can implement a certain algorithm, you can use this theorem para i-compute niya yung GCD. Ang gagawin naman ng algorithm, i-compute lang niya yung mga value na to, tapos kukunin lang niya yung pinakamaliit. And that's already the GCD. So that's one way of determining the GCD. Yeah. And we can write that as a corollary. If A and B are integers, not both zero, then this set containing all linear combination ax plus by is precisely the set of all multiples of the GCD. Lahat yan multiples ng GCD. That's easy to show. For example, if M is in T, isa siyang ax plus by, isa siyang linear combination. Tama? So, ibig sabihin, pwede mong isulat si M as ax plus by. Tama? Pero since D both divides A and B, so here we let D equals GCD ng AB. And D divides both A and B. So that would necessarily mean na D divides any linear combination. So D divides AX plus BY. Or that means D divides M. So if D divides M, then by our definition, M is a multiple of D. Ibig sabihin, kahit anong laman ni T, multiple siya nung divisor. Kahit anong laman ni T, multiple siya nung divisor. On the other hand, if ND is a multiple of the divisor, kung for example, meron tayong N times D, this is a multiple. Pwede naman natin isulat si ND as, by the previous theorem, N times AX0 plus BY0. Di ba? Si GCD daw, you can always be written as a linear combination AX0 plus BY0. There exists such X0, Y0. Anong ibig sabihin nun? Nasulat natin si ND as A times NX0 plus B times NY0. So, ibig sabihin, si ND ay linear combination ng AB. So, nasa T siya. So, pag nasa T ka, multiple ka ng divisor. Pag multiple ka ng divisor, nasa T ka. So, in a way, binibigyan niya tayo ng algorithm para malaman kung ano yung mga multiples ng divisor. Kunin mo lahat ng linear combination AB and that gives you the multiples of the divisor. So since ang mga laman ng set na to puro multiple ng divisors, hanapin mo yung pinakamaliit na positive value, then that gives you the GCD. Okay? So this gives us a way to determine the GCD. Yun nga lang hindi madali yung process ng paghanap ng linear combinations. But at least, we have a good property of the GCD. Ano yan? Siya yung least possible value of all linear combination AX plus BY. Ibig sabihin, pag binuo mo yung set T mo, okay, kinuha mo yung mga positive, tapos kinuha mo yung pinakamaliit, yun yung least common divisor. Or, pwede rin, the positive common divisor that is divisible by all the other common divisors. Kasi ang lahat ng magiging laman nito, mga divisors. Tama? Mga multiple ni D. So, kung mga multiple ni D yan, lahat yan divisible by D. Okay. So, parang sinasabi niya na pwede mo ring sabihin na ang greatest common divisor ay yung divisor kung saan kaya niyang divisible by all other. Ibig sabihin, multiple siya ng lahat ng iba pang divisor. So, it's another criteria. If C divides A and C divides B, then C must divide the greatest common divisor. So, of course, a common divisor should always divide the greatest common divisor. Yan. Kasi kanina ang definition lang natin ng GCD, di ba? Common divisor siya. Tapos sa lahat ng common divisor, siya yung pinakamalaki. This time, we can add, kahit na hindi mo alam kung siya yung pinakamalaki, basta madidivide siya ng lahat ng iba pang common divisor, then automatic, siya na rin yung GCD. Well, in fact, this is already established by the property of divisibility. Kasi di ba nga, pag ang C divides D, then that implies na ang absolute value ng C less than or equal to absolute value ng D. Yung D positive. So that means C is less than or equal to D. Okay? So, pwede rin ito criteria. So, either ito gagamitin mo o ito gagamitin mo. So, a common divisor, meaning nadidivide niya si A at B, na either pinakamalaki or multiple ng lahat. Yan. So, siya yung GCD. Okay, so these are very common properties of GCD. We already know this. Ginagamit na natin siya actually if we have integers A and B, not both 0. For any positive integer M, ang GCD ng MA times MB is M times GCD ng AB. Ibig sabihin, pwede nating i-factor out yung common factor ng AB sa GCD. This is a technique we use para mas madali nating mahanap yung GCD. Pina-factor out muna natin yung common hanggang makita natin yung GCD ng mas maliit na pair ng number. Ayan. If C divides A and C divides B, pwede mong gawin ay i-divide yung nasa loob ng C, ng common divisor. So, liliit yung value, yung A over C, tsaka B over C. Pag kinuha mo yung GCD nun, pareho lang din yon sa kunin mo yung GCD ng AB times C. Okay. So, ibig sabihin, parang yun yung kanina, in-apply mo lang yung number 1 sa number 2. Yung C, pag minultiply mo sa kabila, para mong kinuha yung common factor ng AB. Yan. And, isa pa, if D is the GCD, so, ibig sabihin, pag ang finactor out mo sa AB ay yung greatest common divisor, yung A over D tsaka B over D, ang GCD niya, 1 na lang. Okay? Number 3 actually follows directly from number 2. You just get C equals GCD ng AB. So, kunin mo lang, ang gawin mo lang, ang ipang-divide mo sa A, yung GCD niya. Diba? So, ibig sabihin, once na-establish mo na yung 2, 3 will immediately follow. Kasi magiging equals 1 na lang. Okay? So, ipakita lang natin yung 1 and 2. Yung number 3 will immediately follow from, yung number 3 rather, will immediately follow from number 2. And madali lang naman gawin yan. Ano lang naman yan, definition. Okay? Special case, when the GCD of two numbers is 1, ang tawag natin doon, relatively prime. Relatively prime, ibig sabihin, wala nang common factor other than 1, si AB. So, pag ang GCD ng AB ay 1, ang tawag natin sa pair of numbers na yun, relatively prime. In a way, yes, it's also related to the definition of prime numbers. Pero next lesson na natin pag-usapan yung prime numbers. Okay, so let's prove number 1 and 2. Yan. So let m be a positive integer. So we want to show na ang GCD ng MA times MB pareho lang sa M times GCD ng AB. Yan. Okay. Ano ba yung GCD ng MA tsaka MB? Sabi natin, yung theorem kanina, it's the least positive value of the linear combination. Di ba? This is the least, smallest positive linear combination ng MA tsaka AB. So, MA x plus MBY. So, kunin mo lahat ng linear combination ng MA tsaka MB. So, that's MAX plus MBY. Kunin mo yung pinakamaliit. Yun yung GCD. Yan. Yun yung sabi ng theorem natin, di ba? Okay. So, kumbaga, meron kang set, yan, MAX plus MBY. Such that positive. Include natin yung requirement na positive. Tapos, sa set na yan, kunin mo yung least element, yung minimum ng set na yan. Yan. Yun yung magiging GCD mo. Okay. Pero, lahat na yan, nakamultiply ng M. So, pwede mo yung isulat as minimum ng set na M AX plus BY. Tama? Pero syempre, kung ano man yung minimum nito, i-times mo sa M, pareho lang din yon sa minimum nung set na yan. So, pwede rin naman na kunin mo na lang yung minimum nung set na AX plus BY. Tapos yung value niya, i-times mo ng M. Kung ano man yung makukuha mong minimum nito. Tama? O, by definition, saan ba equal to? Minimum ng linear combination ng AB. Then sa GCD ng AB. Okay. So, ang GCD ng MAMB, pag may common factor, pareho lang yung sa ilabas may common factor, kunin mo yung GCD ng natira. Yan. So, we can use that to prove 2 actually. So, what if C divides A and C divides B? Common divisor yung C. Gusto natin ipakita na ang GCD, pag dinivide mo yung AB ng C, pareho lang yun sa GCD ng AB na dinivide ng C. Yan. Okay. So, again, if C is a common factor, di ba? If C is a common factor, ang ibig sabihin nito, yung A, pwede mong isulat as C times something. Yung B, pwede mong isulat as C times another integer. Ibig sabihin, yung A divided by C, integer yon. Yung B divided by C, integer din yun. Ha? Yan. So, meron kang dalawang integer. AC tsaka BC. So, pag kinuha mo yung GCD ng AB, pareho lang din siya sa kinukuha mo yung GCD ng, well, alam natin na yung A, pwede mong isulat as A, rather, C times A over C. Yung B, pwede mong isulat as C times P over C. Tama? Yan. Q1 to Q2. Kumbaga kasi yung A is C times Q1, yung B C times Q2. Yung Q1, yun yung A over C. Yung Q2, yun yung B over C. Yan. Okay. So, lahat na yan, divide mo ng C. Pero saan ba equal itong nasa right-hand side? Sabi ng number 1, pag may common factor ka sa loob, pwede mong ilabas yung common factor. So, gamit yung number 1, pwede mong ilabas yung common factor na C. So, this is yung yung numerator ay C times GCD nung nasa loob na A over C tsaka B over C. Tapos lahat yan, nakadivide ng C. So, cancel yung C. So, ang natira na lang ay GCD ng A over C, B over C. Which is what we want to show, di ba? Ang GCD ng AB over C ay GCD ng A over C, comma, B over C. Yun. And of course, if we take C to be the GCD itself, di ano mangyayari? So, ito magiging 1. Yung left hand side magiging 1. Ito magiging GCD ng A over D, B over D. Yung D natin ay yung GCD ng AB. Pag ginamit mo dito sa number 2 na C ay yung value ng GCD, magiging siya yung number 3. So, napakita na rin natin yung number 3. Okay? Yan lang kadali. Yan. Okay. So, tuloy natin yung properties. If GCD ng AC is equal to 1 and GCD ng BC is equal to 1, ano ibig sabihin nun? A and C are relatively prime. So is are B and C. So relatively prime si A at C, relatively prime din si B at C. Then the GCD of A times B and C is equal to 1. Ibig sabihin, relatively prime din yung product ng AB sa C. Yan. Madali lang ipakita yan later. Number 5, if A divides C and B divides C, so common factor yung, hindi common factor, both A and B divides the same number. Yan. So si A, factor siya ni C, si B, factor din siya ni C. So the GCD of AB with GCD of AB equals 1. Then the product AB divides C. Euclide's lemma, if A divides BC and the GCD of AB is 1, so si A daw, nadidivide niya yung product na BC. Pero si A, relatively prime kay B. So ibig sabihin, si A, hindi niya madidivide si B. Wala siyang common factor. GCD niya ay 1. Ibig sabihin, dapat si A, ang madidivide niya si C. So pag ang A, nadidivide yung product, at relatively prime siya kay B, dapat ang kaya niyang i-divide yung isa. So if A divides the product and A is relatively prime to one of the factor, then A must divide the other factor. Yan. Kasi ang ibig sabihin, pag ang GCD ng dalawang number equal sa 1, ibig sabihin, hindi madidivide. Ayan. Pag ang GCD, unless equal sa 1 pareho, ay equal to 1, then ibig sabihin, si A, kung siya yung mas maliit kaysa B, ay hindi factor ni B. Or si B, hindi factor ni A. Again, except when the case when both A and B are 1. Of course, pag ang isang value dyan, 1, edi talaga ang GCD niya magiging 1. So, for non-trivial cases, ang ibig sabihin ng GCD 1 ay hindi factor ng isa yung isa. Okay. So anyway, so let's show number 4 first. We want to show that if the GCD of AC is 1 and the GCD of BC is 1, then the GCD of the product AB and C is also 1. Again, we always go back to the definition. Ano ba definition ng GCD ng AC equals 1? Ibig sabihin nun, dapat makakakita tayo ng x0, y0, there exists such that pwede natin isulat yung GCD as the linear combination. So 1, which is the GCD, is equal to AX0 plus CY0. Similarly, since the GCD of B and C is also equal to 1, then dapat makakakita rin tayo ng, gamit tayo ng ibang letter, U0, V0, such that C1, pwede natin isulat as B na pala, sorry. B, U0 plus C, V0. Yan. Again, don't abuse your notation na pagka ibang property or pag ibang expression, expressing the same property, just use a different variable for that. You can use different letters or you can use subscripts. Yan. Kaya lang dito, kaya hindi ko sinubscript na x1, y1 kasi sub-0 yung ginagamit nating subscript para doon sa GCD niya. Now, if we combine these two expression, di ba? Meron tayong expression containing AX tsaka BU0. Gusto kasi natin pagsamahin yung AB. Bakit? Kasi yung conclusion natin involves the GCD of AB and C. Yan. It involves the GCD of AB and C. So, kailangan natin ng linear combination ng AB. Saan natin kukunin? De sa dalawang equation na yan. So, these two will imply that first, AX0, pangalawa, BU0 is equal to, so lilipat lang natin sa kabila, 1 minus CY0. 1 plus, minus CV0. Okay? So, pag sinimplify natin yan, de 1 minus CY0 minus CV0 plus C squared Y0 V0. Simple arithmetic lang naman. Okay. Para hindi magulo, tawagin natin yung X0, ito. Diba? Meron tayong, ang makikita natin, meron tayong AB times, tawagin lang natin siyang X. Ayan. Equals 1. Tapos ito lahat, ito. Lahat siya may C. Diba? Common factor niya yung C. Tawagin natin siyang minus CY. Alin yung Y? So, kanina, yung X pala, just to be clear, X0, Y0. Tapos, dito, yung C, pag pinactor out mo, okay? So, yung Y, lahat nung natira sa factor, yung Y0, yung minus, pag pinactor out mo, yan. So, magiging plus V0. Yung plus, pinactor out may negative, so magiging minus CY0, B0. So, pinactor out mo lang yung isang C. Yan, para hindi lang magulo. Okay. So, nasulat natin yung 1 to be A, B, X plus CY. 1 is a linear combination of A, B, and C. 1 is a linear combination of A, B, and C. Ano nga ang sabi natin sa mga linear combination? Pag kinuha mo ang lahat ng linear combination ng A, B, and C, ang ibig sabihin nun, kinukuha mo yung multiples ng divisors ng A, B, at C. Tama? Yan lahat yung mga divisors ng AB at ng C. So, lahat yan ay multiples ng divisors. Ibig sabihin, pag kinuha mo yung pinakamaliit dyan, yan yung GCD. Tama? Pag kinuha mo yung pinakamaliit dyan, yan yung GCD. This is one of the divisors. Sa isang set na ang laman puro positive, di ba? Ang mga laman mo lang puro positive. Ano ang smallest possible value? Ang smallest possible value, 1. Wala nang mas lilit pa sa 1. Eh nakita natin na ang 1, laman din ng set na yon. So ibig sabihin, yan ang pinakamaliit. Basta nag-exist yung 1, siya na yung pinakamaliit doon. Eh sabi natin, pag kinuha mo yung pinakamaliit nito, ang pinakamaliit nito, nung T, eh yung GCD. Di ba? Ang pinakamaliit sa T, yung positive na pinakamaliit sa T, ay GCD. Ano ibig sabihin? So, 1 is equal to GCD ng AB tsaka ng C. Yan. I hope that's clear. Ang sinasabi natin dito, dahil na-express natin yung 1 as linear combination ng AB tsaka ng C, in reference to our theorem, sabi natin, di ba, pag binuo mo yung lahat ng linear combination ng AB times some number plus C times some number, yan. Lahat ng positive na laman yan ay divisor ng AB tsaka ng C. So, kung kukunin mo yung pinakamalit na laman niya, sa yung GCD. Okay? Ay, rather multiple pala, sorry. So, yung multiple ng mga divisor. So, pag kinuha mo yung pinakamalit na laman niya, sa yung GCD. Ayun. Eh, dahil yung 1 nandoon, so yung 1 na yung GCD, kasi yung 1 yung automatic na magiging pinakamaliit. Okay. So, napakita natin, ito, pag relatively prime yung AC tsaka yung BC, yung product na AB, relatively prime din sa C. Next, if A divides C and B divides C with GCD ng AB equals 1. Ganun ulit. Hanapan mo lang ng linear combination. Yung AC, yung A, B, tsaka C para mapakita mo yung product na AB divides C. Okay. So, simulan natin dun sa given. Sabi ng given, A divides C and B divides C. Okay. Ano ulit ibig sabihin by definition? By definition, si C, pwede mong isulat as A times Q1. Si C, ganun din. Pwede mong isulat as B times Q2. So, nasulat mo si C as linear combination, as product ng A times Q and Q1, tsaka B times Q1. Okay. Since the GCD ng AB is 1, tama? GCD ng AB equals 1, then pwede mong isulat si 1 as linear combination AX plus BY0. There exists, ibig sabihin niyan, there exists, makakakita ka, fix na yung X0, Y0 para doon sa 1 na yun. So there exists X0, Y0 such that 1 can be written as AX0 plus BY0. Okay. So, pagsamahin natin yung dalawa. C times 1, C muna is equal to C times 1. Pero, ang C, ang 1, in-express natin as AX0 plus BY0. Right? Okay. Now, CA can be written as C sorry, ano na yung value natin kanina? Times C, mali ako, times C. Sorry. This is times C. So, si C, pwede natin i-multiply CA X0 plus B CBY0. Yan. Okay. Pero, si C ay equal sa BQ1. Tama ba? O BQ2? BQ2 rather. Si C, so this is equal to BQ2A X0 plus si C, pwede rin nating isulat in terms of A. So si C ay yung pangalawang C na to, pwede nating isulat in terms of A. So that's AQ1 BY0. Yan. So ano nangyari? Parehong may AB. Tama? Wala na akong space. Okay. Parehong may dito lang sa gilid. I-factor out natin yung AB. So ang matitira ay Q2 X0 plus Q1 Y0. Okay. Well, anong ibig sabihin yan? Nasulat natin yung C as product ng AB times integer. Tama? C is equal to AB times integer. By definition, of divisibility, AB divides C. Which is what we want to show. Diba? Yun naman yung gusto natin pakita eh. Yan. Okay. And finally, suppose A divides B and the GCD of AB is equal to 1. So yun yung sabi natin kanina, since ang GCD ng AB equal sa 1, ibig sabihin, walang common factor si A at si B. So in terms of divisibility, si A, hindi niya kayang i-divide si B. Pero kung madidivide ni A yung product at hindi niya kayang i-divide si B, dapat si C yung kaya niyang i-divide. Tama? Para ma-divide mo yung product, kailangan at least may isa kang pwedeng i-divide sa kanila. Yan. Pag hindi mo kayang i-divide yung isa. Okay. Pero this is not true pag parehong kayang i-divide ni A, si B at si C. Okay. Nagiging totoo lang siya, yung conclusion na to, magiging totoo lang pag ang GCD ng A tsaka ng B, 1. Kasi for example, ang 4, kaya niyang i-divide yung 2 times 6. Pero, hindi ibig sabihin, ang 4, kayang i-divide yung 6. Tama? Bakit? Kasi ang 4, hindi relatively prime sa 2. May GCD ang 4 at 2. 2, hindi 1. Kaya hindi magwo-work yung theorem pag hindi mo sinali to. So, magwo-work lang yung theorem pag si A relatively prime sa isa sa kanila. Okay? So, for example, si 4, pwede mong isulat as 3, yung 12, pwede mong isulat as 3 times 4. O, yung 4 tsaka 3, relatively prime na. So, si 4 divides 4. Pag hindi nangyayari to, hindi mo mako-conclude ito. Yan. So, again, I leave that as an exercise. Madaling exercise lang yan. Kayang-kaya niyan. Okay? Kagaya nyo lang ginawa ko sa number 4. Express nyo lang yung ibig sabihin ng A divides B. At saka yung ibig sabihin ng GCD. Tapos, kukunin mo yung C, dapat makahanap ka ng common factor A. Ganun lang. Pag nahanap mo na yung C equals A times something, edi ang ibig sabihin na A divides C. So, please make sure to do the exercises. Kung nagugutom na kayo, pwede kayong kumain while listening to me. Okay lang yan. I continue with the last topic for this day. Given two integers A and B, not both 0, and any integer x, then the GCD of AB is equal to GCD of A and negative B, which is the same as GCD ng BA, kahit baliktarin mo, which is the same as GCD ng B times A plus BX. I'll no longer show this and will proceed with the Euclidean algorithm, pero this is a very important lemma. Okay? Bakit yung lemma na to, ang sinasabi niya, pwede mong palitan yung GCD ng negative B. Pareho pa rin yung makukuha mo. Pwede mong pagpalitin yung position ng B at A. Pareho pa rin yung makukuha mo. At pwede mong palitan yung A ng A plus BX. Here, X is any. So, X is any integer. So, sobrang lakas nung lemma na to. Kasi, ibig sabihin, if I replace yung content ng GCD, pareho pa rin siya sa original. So, pwede kong paglaruan yung nasa loob, pero yung original GCD, hindi nagbabago yung value. Yan. So, yun yung mga kailangan nating property para sa Euclidean algorithm. Pwede mong palitan ng negative yung isa, pwede mong pagpalitin ng posisyon, or pwede mong tanggalin yung isa, tinanggal mo, papalitan mo ng A plus BX. A linear combination, a specific linear combination ng AB. A plus BX. Yan. Okay. So later, I'll illustrate the process as I explain the Euclidean algorithm. So ano ba yung Euclidean algorithm? So ganito yung Euclidean algorithm. Yan. So at first, medyo komplikado siyang tingnan, pero that's easy to remember or easy to follow. Given integers A and B where B is positive, we make a repeated application of the division algorithm to obtain a series of equations. So, paano ginagawa yung series of equations? Una, division algorithm sa AB. So, by the division algorithm, pwede mong makuha yung Q1 tsaka R1 and express A to be equal sa BQ1 plus R1. Madali lang yon. Yun yung unang-una natin ginawa. Of course, ang magiging restriction nito, R1, is between 0 to B1. Now, bakit ko inalis yung equality sa 0? Ayan. So, kasi pagka yung R natin nag-equal sa 0, ibig sabihin, ang A ay multiple ni B. So, hindi na natin kailangan ituloy yung division algorithm. Tapos na division algorithm doon. And in the point of view of Euclidean algorithm, tapos na rin yung Euclidean algorithm. So, hanggat hindi 0 yung remainder, tutuloy ka sa susunod. So, ano yung susunod? Instead of A na yung gagamitin mo, tsaka yung B, papalitan mo yung A. Gagawin mong B, tsaka yung R1. Pero this time, yung B na yung magiging dividend, yung R1 yung bagong divisor. Okay? So, kanina sa AB, yung A yung dividend, yung B yung divisor. So, may makukuha kang Q1 tsaka R1. Pag yung R1 hindi 0, tutuloy mo yung division algorithm. Pero this time, B at R1 naman. So, B yung dividend, R1 yung bagong divisor. So, makakakita ka ng Q2 tsaka R2 satisfying the division algorithm. Kung saan B is equal to R1 Q2 plus R3. Okay. R2 rather, sorry. So, this time, R2 is between 0 to, yung bagong divisor natin, yung R1. So, 0 to R1. Now, kung yung R2 mo nag-0, stop na yung algorithm. Pero kung hindi pa, tuloy mo ulit. So, this time, ang gagamitin mo naman, R1 na yung bagong dividend. So, dito sa second step, ang makukuha mo, Q2, R2. So, ang bago, sa susunod na step, kukunin mo yung R1, tsaka yung this time, yung R2. So, para madaling tandaan, itong position na to, tsaka yung position na to. So, yung B pupunta doon, yung R1 pupunta doon. Yan. So, sa susunod na algorithm, yung R1 na yung magiging dividend, yung R2 na yung magiging divisor. Yan. So, may makukuha ka ulit na pair na Q3, R3 such that R1 is equal to R2, Q3 plus R3. Where R3 is between this time, this should be R3, yes, and this should be R2. Okay, tama naman. So, R3 is between 0 to R2. So, gagawin mo yon hanggang maging 0 yung R2. ay Rn rather. Pag nag-zero na yung remainder, for example, nasa dulo ka na, plus 0, stop ka na. Wala nang susunod na step pag zero na yung remainder. Now, ultimately, magiging 0 talaga. Bakit? Kasi, laging ang R natin, di ba, R1, strictly less than B. Yung susunod na R2, strictly less than R1. Yung susunod na R3, strictly less than R2. Paliit ng paliit yung R1, R2, R3, and so on. This is a decreasing sequence. Siyempre, pag ang isang sequence decreasing, edi ng mga positive, ng mga non-negative integers, lahat yan non-negative kasi 0, 0, 0. So, paliit siya ng paliit. So, dahil paliit siya ng paliit, eventually, darating ka sa point na magsisiro na yan. Kahit saan ka mag-start. Kahit yung B mo, 1 million. Yung susunod na value R mo, mas maliit dapat sa 1 million, di ba? So, eventually, yes, magiging 0 yung remainder. Once na naging 0 na yung remainder, stop na yung algorithm. Okay. Yung last non-zero remainder, that's actually the GCD of AB. That's actually the GCD of AB. Okay. Now, it's easy to see na divisor siya. Bakit? Divisor siya kasi, di ba nagsimula tayo dun sa unang division algorithm natin. A is equal to BQ1 plus R1. So, pwede nating isulat mula dito, pwede nating isulat si Rn as linear combination. Diba? Hindi pala mula rito, mula dito. Pwede mong isulat si Rn as linear combination ng Rn minus 2 and Q. Q, that should be Qn. Tama? Pero, yung mga value na nandito, yung value na to, tsaka yung value na to, galing siya dun sa naunang expression sa kanya. So, ito, pwede mong palitan ng naunang expression. So, pwede mo siyang isulat as linear combination nung nauna sa kanya. Tama? Tapos, yung nauna sa kanya ay linear combination nung nauna pa sa kanya. And so on. So, if we reverse the process, eventually, darating tayo sa isang linear combination involving the very first one. So, magkakaroon ka ng linear combination involving A plus linear combination involving B. By back substitution. Eventually yan. Without specific example kasi mahirap ipakita. Pero eventually, darating tayo sa linear combination ng AB. So, napakita natin na ang Rn ay linear combination ng AB. And this is true for any step. Okay? Kahit sa Rn sub 1 ka mag-start or sa R1 ka mag-start, lahat yon linear combination ng AB. So, lahat yon divisor ng AB kasi linear combination siya ng AB. Tama? Pero, since papaliit tayo, so siya yung pinakamaliit sa lahat ng linear combination. So, that means siya yung magiging GCD. Okay? Let's illustrate the process. Yan. This process is used in finding, this is a very prominent process in finding the GCD of two numbers. And this is named after Euclid in honor of him being the one who discovered or pioneered the algorithm. For example, 954 and 738. Of course, for small number, madali lang namang hanapin yung GCD. Pero once lumaki na yung number, medyo mahirap nang mag-factor. Yan. So, dito pumapasok yung Euclidean algorithm. Okay, let's use Euclidean algorithm to find the GCD of 954, and 738. So, anong gagawin natin? This is just a series of application of the Euclidean algorithm. The division algorithm, rather. Sorry. The division algorithm. So, anong gagawin mo? You start with A, B, and you express this as BQ1 plus R1. Yan. Okay. So, una, ito yung A, ito yung B. So, we have 954 is equal to 738 times something plus a remainder. So, ang gagawin mo lang, you get a calculator, gagawin mo na 954 divided by 738, that's 1 point something. So, this is just 738 times 1 plus, so, ima-minus mo lang, 954 minus 738. So, that gives us 216. So, yung makukuha mo dito, siya yung R1. So, ang gagawin mo, yung B, i-express mo as R1 times Q2 plus R2. So, yung B naman, 738 is equal to, using this time R1, 216 times something plus something. So, hanapin mo lang yung Q niya. So, paano gagawin yun? 738, di-divide mo lang ng 216. So, 738 divided by 216, more or less, that's 3 point something. Yan. So, ibig sabihin, pwede kang kumuha ng 3 times 216, then, i-minus mo sa 738. So, 738 minus 3 times 216, if you have a calcul, that will give us 90. Tama? So, ito na yung R2. Now, hanggat hindi nagsisiro yung R, tuloy mo lang. So, this time, R2 naman yung i-express mo na R1 muna. R1, i-express mo in terms of R2 times Q3 plus R3. So, ibig sabihin, si 216 naman, ang i-equal mo sa 90 times something plus something. Hanapin mo naman yung QR niya. Okay? So, 216 divided by 90. 90, mga 180, no? Mga dalawa, 2 times 2. So, that's 2. So, 180 minus mo sa 216. So, 216, that's 36. Yan. So, this becomes your R3. So, now, you use R2 equals R3. Compute mo yung bagong Q. Q for R4. So, 90 naman, yung hahanapan mo ng 36 times something plus something. So, gano'n ulit. 90 divided by 36. 2. 72, no? Kasi 36 times 3, lalagpas ka na ng 100, eh. So, 2 ulit. So, 36 times 2, 72. 90 minus 72, 18. So, this is your R4. So, R4 is equal to R3, R3 muna. R3, R4, Q5 plus R5. So, 36 is equal to 18 times something plus something. So, this time, 36 is divisible by 18, so that's 2 plus 0. So, now, nakakuha na tayo ng 0, so we stop the algorithm. Since ang last non-zero na remainder ay 18, therefore, the GCD is equal to 18. Now, how do we write this as linear combination? So, gagawin mo lang, babalik ka lang. Magsisimula ka dun sa huling non-zero remainder. Tapos, you work your way back. Pabalik. Okay? Paano babalik? Simulan natin. Paano mo express ang 18 as linear combination ng 954138? So, start ka dito. Dito ka mag-start. Yan. Kukunin mo yung 18 kasi 18 yung GCD, eh. So, dapat maging 18 equals. Yan. So 18 equals, so from here, that's 90 minus, so tabi nyo to, kailangan nyo to sa solution. Pabalik. 36 times 2. Pero alam natin na yung 90 tsaka yung 36, galing yan sa previous equation. So, ang gagawin mo, papalitan mo yung, syempre sunod-sunod ang palit. Ayan. So, papalitan mo muna dapat yung kasunod ng R4, yung R3 muna. Sunod-sunod yung pagpalit. Hindi pwedeng sabay-sabay. Okay. So, yung 90 minus 36 times 2, pwede mong palitan yung 36 gamit yung previous equation. Yan. So, this becomes 90 minus yung 36, i-express mo as this 2. 216 equals 90 times 2. 216 minus 90 times 2. Right? Of course, this expression can be simplified as collect mo yung common factor ng 90. Di ba? So, meron kang wait, nawala yung times 2 ko. Sorry. May times 2 pa yan. Sa labas. 36 pa lang to eh. 36 pa lang yan. Times 2 pa. Ayan. So, yung 90, may 90 kayo dyan. Ko-combine mo lang yung common factor. So, this is 2 times 2. So, negative 4 times negative 1. So, plus 4 plus 1. So, 590. Tama? So, that's negative 2 times 216 plus 5 times 90. Yan. Okay. Now, kanina pinalitan natin yung 36, yung R3. Ngayon, ang papalitan mo na yung R4, ay yung R2, sunod-sunod pabalik, which is yung 90. So, ito yung sunod papalitan. Yung 216, hayaan mo lang muna. So, negative 2 times 216 plus 5 times. Okay, so gamit ito, nasa R2 na tayo, palitan mo yung 90 ng 738 minus 216 times 3. 738 minus 216 times 3. Tama? Double check. 216 times 3. Okay. So, if you simplify this, yan. So, yung 216 dito, naka-times 3. Tapos, times 5. So, negative 15 minus 2. So, minus 17. So, meron tayong 5 times 738 minus 17 times 216. So, this time, yung 216 naman, ang papalitan natin. Isa-isa, huwag mong bibiglain. 216. So, pagkatapos ng 90, pagkatapos nito, 216 naman. So, saan ba equal yung 216? 954 minus 738. So, this is equal to 5 times 738 minus 17, 954 minus 738. So, pagsamahin lang natin yung 738, this is negative 17 times negative 1. So, that gives us plus 17. Tapos may plus 5 pa. Tama? So, 22. So, we have 17 times 954 plus 22 times 738. Ngayon, this is already the last. So, nandun na yung 954 tsaka 738. So, ito na yung 954. Ito na yung 738. So, 18 is equal to a linear combination ng A tsaka ng B. Negative 17 yung X0, positive 22 yung Y0. X0 plus Y0. Okay? So, that's the power of linear algorithm. Kahit na malaki na yung value ng A tsaka ng B, of course, some of you can still try to get the GCD na ifa-factor yung 954. Nung high school, ganun ginagawa natin, di ba? Okay lang yun. 738. So, ginagawa natin, pina-factor natin, 954 divided by 2. So, 2 times, kukunin mo yung prime factorization. Tapos, 738, 2 times 2. Basta yung kung ano man yung prime factorization niya. Tapos kukunin mo yung mga common factor, tapos i-multiply mo. That's the GCD. That's also a valid technique to find the GCD. Now, bakit nice yung algorithm na to? Nice yung algorithm na to kasi hindi mo kailangang malaman yung malalaking factor. Sometimes, it can happen na pag malalaki na yung number, mahirap nang hanapin yung mga factor. Yan. Pero, the division algorithm is very easy to conduct. Diba? Madali lang para sa atin na maghanap ng Q1, R1 for any two pair. For any two pair of AB, we can always find Q1, R1. So, this is an example of a deterministic algorithm that ends, that terminates. So, kung meron kang malaking number, ang gagawin mo lang, ipoprogram mo lang yung Euclidean algorithm and eventually, it will be able to give you the GCD of two numbers. Yan. Of course, the bigger the number, the longer the algorithm works. Ibig sabihin, mas matagal na oras ang kailangan para gawin yung algorithm. But the nice thing about it is that you are sure na matatapos yung algorithm. And most operation research problem are focused on determining whether an algorithm will terminate or not, and whether it will terminate in a polynomial time. Later in your future higher math subject, pag sabi mo polynomial time, ibig sabihin nun, it's a time na kayang ma-predict in a polynomial order. Kumbaga, in terms of process or operation process, yun yung mga magte-terminate in a lifetime. Ibig sabihin, pwede mong gamitin yung algorithm to perform a certain task. Pero pag ang time is exponential, yan. So ibig sabihin, matagal bago ma-solve ng algorithm yung specific process na pinapagawa sa kanya. So in operation research, what we want is an algorithm that terminates in an acceptable amount of time. Yan. So this Euclidean algorithm is an example of that. So alam natin na magte-terminate siya. Yan. Okay? So as exercise or practice, maganda gawin nyo rin on your own. So try to find the GCD of the following, and then try to express the GCD as linear combination of A and B. Yan. So, kumbaga, hinahanap yung D equals AX0 plus BY0. And you can only do this using the Euclidean algorithm. Well, pwede mong hulaan, pero pag malalaki na yung number, syempre, ang hirap ng hulaan, di ba? 48,411 at saka 85,671. Ayan. Sinadya ko talagang lakihan para mahirapan kayong manghula ng X0, Y0. Madali nyo mahanap yung GCD, yes. Pwede nyo gamitan ng factor yan. Diba? Pero, yung susunod na problem nyo, paano mo express as linear combination? Kung di ka dadaan sa Euclidean algorithm, may hirapan kang hanapin. Kaya kailangan mo matutunan yung Euclidean algorithm talaga para ma-express mo as linear combination. Yan. Okay. Sige, dagdag na lang tayo ng ibang number. 1109 tsaka 4999. Medyo mas maliit ng konti. Tsaka 7469 and 2464. Unahin nyo yung 2, 3, bago yung 1. Yung 1 medyo malaki na para ma-practice muna.
Sir?
Yes po.
Final na po ba talaga yung 1?
What do you mean final na yung 1?
Ang laki po.
Kaya nga doon yung ma-appreciate yung Euclidean algorithm. Yan. Huli natin to, huli. Yan, dito natin siya ilagay. Yan. Para hindi niyo unahin. Yan, diyan niya ma-appreciate yung Euclidean algorithm. So again, pwede niyong i-try na hanapin yung GCD by factoring. That's okay. Pero dito kayo may problema pagka factoring ang ginamit niyo. Doon sa another task na kailangan nyo i-express as ax plus by plus 0. So again, that's just continued application of the Euclidean algorithm. Actually, yung number 3, matatapos man in 7 steps. After 7 division algorithm, magsisiro na yung ano. Magsisiro na yung, magte-terminate na yung process. Okay po. So I guess that concludes our discussion for divisibility of integer. Now, next week will be our midterm. So, just practice yung lessons natin today. Later, I'll upload some exercises para may ma-practice naman kayo. The coverage of our midterm will be from the beginning, introduction to number theory, up to this time. Actually, konti lang yung lesson na yun. 3 lang. Ano ba na-discuss lang natin? The well-ordering principle, yung intro nga, yung sa well-ordering principle, yung induction, yung binomial theorem, and then this divisibility of integers. And that will be the content of our midterm exam. So parang nung mga last sem midterm din, ganun ulit, multiple choice exam, pero magdadagdag tayo ng item na required mag-upload ng solution. So that I know kung naintindihan nyo ba or not, specifically yung Euclidean algorithm. So I'll ask a solution for the Euclidean algorithm. At saka sa induction. Kasi mahirap mag multiple choice or mahirap ma-determine kung naintindihan nyo ba yung concept ng or yung process ng induction at ng Euclidean algorithm kung multiple choice yung tanong. So for those questions, magdadagdag tayo ng pagsasubmit ng solution. So, reminder ko lang, when you submit your solution, always convert it to PDF kasi nakalimit yung form na mag-accept ng PDF lang. Last year kasi may mga nagka-problema na nagsasubmit sila pero ayaw daw ma-accept ng form. Pero pwede nyo rin namang isubmit sa classroom. Kaya lang, nung tingnan ko yung nasa classroom, naka-PNG pala, naka-JPEG. So, hindi talaga i-accept yun ng form. Kasi nililimit ko sa PDF yung pwede mo lang i-accept sa form. Again, at this point, kung hindi pa nakapag-download ng Adobe Scan, mag-download na ng Adobe Scan para madaling mag-convert to PDF. At least pag naka-Adobe Scan kasi, halimbawa, 7 sheets of paper yung solution mo, picturean mo lang ng sunod-sunod, nakaayos na siya sa Adobe Scan at naka-PDF na din yan. Just make sure na malinaw yung shot. Okay. And also, a gentle reminder, simulan nyo na po yung exposition nyo. If I have some clarification, I'll just mention it doon as comment doon sa Google Docs. Yan. We'll see each other next week for the midterm.
Thank you po, sir.
Bye-bye.